All right, so now that we've talked about what it means to be a similar figure, let's go ahead and look at some sample problems where we use similar figures to solve for missing measures within our similar figures. So we're going to be using ratios and setting up proportions in order to solve for these various variables. So in problem number 4, we're given that the figures below are similar and they actually have a scale factor of 2 to 3, and we're asked to find the value of x. Now we can clearly see by just looking at these visually that the left hand figure is smaller and the right hand figure is bigger. So that's why the 2 belongs to that smaller figure and the 3 belongs to my bigger figure. So that scale factor of 2 to 3. So I can go ahead and start setting up a proportion then. So for my small figure to my big figure, it appears in a scale factor of 2 to 3. And I can set up a proportion according to the numbers and variables that I'm given within this image. Well, then that's proportionally equal to the numbers within my image. So my small figure, I have a measure of 42. And for my bigger figure, I have a value of x, my variable. So I set up this proportion in order to solve for x. I'm going to use the cross product property or cross multiplication in order to solve for x. So here I have 2 times x, or 2x, all equal to the cross multiplication of the other number, so 3 times 42. And let's see, 3 times 42 is 126. So 2x equals 126. I'm going to divide both sides by that 2 to find out what my x value is. And my x value is 126 divided by 2, which is 63. And I'm done. I found my value of x. Now I could check to make sure this is true. So I could say, okay, that 42 on my small figure, when I divide it by the x value that I just found, the 63, my big figure, I should get this fraction, but in, this decimal, but in fractional form. So if I go to math and I choose that frac for fraction and I hit enter again, it spits back the fraction 2 over 3, which is exactly what my ratio or scale factor is, 2 to 3. So this solution does check out. Number 5. If the figures below are similar with a scale factor of 6 to 5, find the value of x. Again, my larger figure has the larger number associated with it, 6, and my smaller figure has the smaller number associated with it, so 5. So these two figures appear in a ratio of 6 to 5, or a scale factor of 6 to 5. So I'm going to use that to set up a proportion. My big figure to my small figure is equal to the values within my big figure versus my small figure. Again, that x was in my big figure, the 28 was in my small figure. So big figure to small figure is equal to big figure to small figure. And I've also matched up those corresponding sides. So I'm going to use cross multiplication in order to solve for this. So 5 times x is 5x, all equal to the other two numbers, 6 times 28. So 6 times 28 is 168. I'm going to divide both sides by that 5, and I get that x should equal 168 divided by 5 is 33.6. So x is equal to 33.6. Again, this is something that I could always check. Well, according to my figure, my x value of 33.6 divided by, so my big figure divided by my small figure, and that number was 28. So 33.6 divided by 28, I get this in decimal form. If I click math, select frac for fraction, and hit enter, I get that ratio spit back, 6 over 5. So my scale factor or ratio is 6 to 5. And so this does check out. Number 6. So if triangle ABC, here we're given a similarity statement. If triangle ABC is similar to triangle DEF, I want you to find the value of x. This similarity statement is very important because it tells us which parts actually match up in the various triangles. So we can then set up the various ratios and proportions in order to solve for that value of x. So here I'm told basically that my side AB and my side DE match up. That's why we were practicing this skill up above, to set up the various ratios and then the various proportions. So side AB matches up with side DE. So this side AB matches this side DE. That's the first ratio I'm going to set up. So this triangle to this triangle is 25 to x. So 25 over x. And now I'm going to set up a proportion that's equal to the other two sides that I have values for. And as I look at, again, the first number I listed on the top was 25, so I need to now steal this number from my triangle. Side BC has a value of 20, and I just need to find its matching part. So BC is the last two letters in my statement here. The last two letters are EF. Hey, that's the side here, which I'm actually given a number for. So 20 over 28 is another ratio I can set up. Now that I have these two ratios, 25 over x and 20 over 28, I've set up a proportion. I've set them equal to each other because these figures are similar. So that means I can set up this proportion and solve for x. So I'm going to use the cross product property. I'm going to cross multiply. 20 times x is just 20x, all equal to 25 times 28. So let's see, 25 times 28 is 700. And if I divide both sides by that 20 in order to solve for x, I get that x is equal to 700 divided by 20 is 35. So continuing on, and I'm going to try to go a little faster. Problem number 7, we're given that this figure PQRS is similar to WXYZ, and we're asked to find the value of x. So as I look at this, I see that one side that I'm given on this larger figure, PS, is 75. And I'm going to find its corresponding part on my other image. So P and S are the first and last letters, so WZ are the first and last letters there. So this is the corresponding side, 40. So I set up that ratio. I'm going to equal that to another ratio that I can set up. So the only other side that I'm given is SR, which is X. And now I need to find the corresponding part in my other image, my smaller image, and it's got to be ZY, but let's just make sure. SR is the last two letters, so the last two letters is YZ. Yeah, it's this side here, the 32. So I'm going to cross multiply, set up my algebraic equation in order to solve for x. So 40 times x is 40x, all equal to 75 times 32 is 2400. I'm going to divide both sides by that 40, and I get that x equals 60, exactly 60. Number 8. Here we're given these figures are similar, A, G, M, and K, X, D. One little thing that might help some of you, especially if you're like visual learners, you might want to mark up your image. So if I'm given that AGM is similar to KXD, start marking up your image. Like the first letter listed there is A, so do 1 arc mark. Second letter is G, so do 2 tick marks. And then the third letter is M, so do 3 tick marks. First letter here is K, so do 1 tick mark. Second letter is X, so do 2 tick marks. Third letter is D, so do 3 tick marks, or 3 arc marks, sorry. And now I can set up my proportions by looking at, okay, between A and G, that's between the 1 and 2 arc marks. So between the 1 and 2 arc marks here, that corresponds to that side. So this side, this triangle over this triangle is 32 over x plus 3. I'm going to set up my proportion then. It's equal to, let's see, I'm also given this side in this triangle, so that's between the second and third arc mark angles. And between the second and third arc mark angles here is this segment. So these two segments are appearing in the same ratio. So 36 over x plus 6. So 36 over x plus 6. So I'm going to cross multiply in order to now solve for x. Here I have 36 times the quantity x plus 3, all equal to the cross multiplication of this, 32 times the quantity x plus 6. So not forgetting that I have to distribute that 36 to both numbers and this 32 to both numbers within that set of parentheses. So 36 times x is just 36x. 36 times 3 is 108. And that's all equal to 32 times x is just 32x. And then 32 times 6 is 192. So I'm going to subtract off 32x on both sides. Cancels out on the right. And I'm left with 4x. 36 minus 32 is just 4. Plus 108, all equal to 192. I'm going to subtract off 108 on both sides. And I'm left with 4x, all equal to, let's see, 192 minus 108, that's 84. And if I divide both sides by that 4, I get that x is equal to 21. All right, looking at this last example, so TLY is similar to CHK, and we need to find the value of x. So I'm going to go ahead and mark up my image here too. So T is the first letter listed, 1 arc mark. L is the second letter listed, 2 arc marks. And then Y is the third listed, so 3 arc marks. Same thing in the other triangle. 1 arc mark, 2 arc marks, and 3 arc marks. So I'm going to first look at this segment TL, which I'm given is 25 units long. And I'm going to set up a ratio. 25 over what matches that in my other triangle? That's the question. So this is between the 1 and 2 arc mark. Here is between the 1 and 2 arc marks. So that's 10. So I set up that ratio. And I'm going to say, well, that's equal to another ratio I can set up in my triangle. So I'm setting up a proportion here. Let's see, the other thing that I'm given in this left-hand triangle is LY, and that's 4x minus 1. Again, that was between the 2 and 3 arc mark. So let's see, between the 2 and 3 arc mark, that's this segment, aka this equation, x plus 5. So I set up those two ratios, and I'm setting them equal to each other, aka I'm setting up a proportion. I'm going to go ahead and cross multiply and solve for x. So 10 times the quantity 4x minus 1 is all equal to the cross multiplication here. So 25 times the quantity x plus 5. And I'm going to distribute that 10 to both of those terms, this 25 to both of those terms. So 10 times 4x is 40x. 10 times 1 is 10. 25 times 1 is 25x. And then 25 times 5 is 125. I'm going to subtract off 25x on both sides. Let's see, 40 minus 25 is 15. And I bring down everything I didn't touch. I'm going to add 10 to both sides. Cancels out. And I'm left with 15x all equal to 125 plus 10 is 135. And all I have to do now is divide both sides by 15. And I get x all by itself. X is equal to 135 divided by 15, which is 9. And I'm done.